Now for these questions, we need to divide a multiple of 10, so a number that ends in a 0, by 10. First, we have 240 divided by 10. That's 24, because what we can do with division problems where we have end zeros, we can cancel the end zeros, and then we have 24 divided by 1, and any number divided by 1 is just that number. So our answer is 24. 240 divided by 10 gives us the same answer as 24 divided by 1. Now we have 4,500 divided by 10. That's 450 because again we can cancel the end zeros, and then we have 450 divided by 1. It's important to understand that we can only cancel one end zero because in the number 10 we only have one end zero, so this zero here has to stay the same. Our answer is 450 because 4,500 divided by 10 gives us the same answer as 450 divided by 1. Now we have 607,060 divided by 10. That's 60,706 because again we can cancel our end zeros. We get the same answer as if we do 60,706 divided by 1. Now what's really happening when we divide by 10 is that digits are moving one place value to the right, because remember, when we have 10 of something we have one of the place value to the left. So for 240 divided by 10, we're moving the digits one square across. Now zeros can disappear off the end of our place value chart, but it's important to understand that if we don't have end zeros, so if we had 241 divided by 10, we wouldn't be able to just get rid of the 1, we'd have to extend our place value chart into decimals. But where numbers end in zeros, we can just cancel the end zeros to get our answer. So for this question, we had 4,500 divided by 10. We can remove this 0 and shift the digits one place value to the right, and that gives us 450 as our answer. And then for this question, we had 607,060. We have a 0 on the end, so we can get rid of the 0, move the digits one place across, and now you can see that we have our answer 60,706. Now for these questions we start with multiples of 100, so numbers that have zeros in the tens and ones, and we're dividing by 100. So first we have 4,300 divided by 100. That's 43, because in the number 100 we have two end zeros, and in division problems we can cancel our end zeros. We have two end zeros in 100, so we can cancel the two end zeros in 4,300, and then we just have 43 divided by 1. And any number divided by 1 is just that number. So our answer is 43. 4,300 divided by 100 gives us the same answer as 43 divided by 1. Now we have 12,300 divided by 100. Again, we can cancel our end zeros, so we get 123 divided by 1, which gives us 123 as our answer. Again, if we have two end zeros in 100, we can cancel two end zeros in our dividend, and that means that we have 123 divided by 1. Now we have 450,000 divided by 100. That's 4,500. We have two end zeros in 100, so we can only cancel two of these end zeros in our dividend. So our answer's 4,500 because 450,000 divided by 100 gives us the same answer as 4,500 divided by 1. And what's really happening when we divide by 100 is that digits are moving 2 place values to the right. Because remember, dividing by 10, we move the digits 1 square to the right, and dividing by 100 is the same as dividing by 10 and then by 10 again. So first, we had 4,300 divided by 100. If we move the digits 2 squares across, the zeros have now disappeared off our place value chart, so we have 43. And it's important to understand that only zeros can disappear off the place value chart. If we had, say, 4,310, we wouldn't be able to move a 1 digit off the place value chart. We would have to extend our place value chart into decimals. But where numbers are multiples of 100, where they have 2 zeros on the end, we can just cancel our zeros to get our answer. So for this question, we had 12,300 divided by 100. So to divide by 100, we can move the digits 2 squares across, and that gives us our answer 123. And for this last question, we had 450,000. To divide by 100, we can move the digits 2 squares across, and that gives us 4,500 as our answer. Now for these questions, we start with multiples of 1,000, so numbers that end in 3 zeros, numbers that have zeros in the hundreds, tens and ones, and we're dividing by 1,000. First, we have 3,000 divided by 1,000. That's 3 because in the number 1,000, we have 3 end zeros, and in division problems, we can cancel our end zeros. So then we have 3 divided by 1, and any number divided by 1 is just that number. So our answer is 3. 3,000 divided by 1,000 gives us the same answer as 3 divided by 1. Now we have 50,000 divided by 1,000. That's 50 because, again, we have 3 end zeros in 1,000, so we can cancel 3 of the end zeros in the dividend. But we can't cancel this end zero here, so we get 50 divided by 1, which gives us our answer of 50. Again, you can cancel the end zeros, so we get the same answer as 50 divided by 1. Now we have 802,000 divided by 1,000. That's 802 because we can cancel 3 of our end zeros. 802,000 divided by 1,000 gives us the same answer as 802 divided by 1. Now what's really happening when we divide by 1,000 is digits are moving 3 squares or 3 place values to the right. That's because dividing by 1,000 is like dividing by 10 and then by 10 again and then by 10 for a third time. And when we divide by 10, digits move 1 square across. So first, we had 3,000 divided by 1,000. Now zeros can disappear off the end of our place value chart, and when we move the digits 3 squares across, we get 3 as our answer. And again, it's important to understand that only zeros can disappear off the place value chart. If we had any non-zero digits in this number, we would have to extend our place value chart into decimals. But here, for these questions, because the numbers that we're dividing end in 3 zeros, we can just ignore those end zeros or cancel those end zeros to give us our answer. For this question, we started with 50,000, and because we were dividing by 1,000, we can move the digits 3 squares to the right, and that gives us our answer of 50, because 3 of our end zeros can disappear off the place value chart, or because we can cancel 3 of our end zeros. For this question, we started with 802,000, So if we move the digits 3 squares to the right, we've divided by 1000 to get our answer 802. Now for these questions, we have some missing divisor problems for dividing by 10, 100 or 1000. And we can tell that the missing numbers must be 10, 100 or 1000 because if we ignore the zeros, we have the same numbers in our dividends and our quotients. So for this first question, ignoring the zeros, we have 4 and 4. For this question, we have 52 and 52. And for this question, we have 83 and 83. So the digits have stayed the same, but they've just moved to a different place value. And that means we must have divided by 10, 100 or 1000. So first, 4000 divided by what is 400? Well, our missing divisor is 10. Because remember, when we divide, we can cancel end zeros, and 400 divided by 1 is 400. So we've cancelled our end zeros, so we know that we only needed to cancel one end zero, so we've divided by 10, which has one end zero. And what's really happened is that we've started with 4000, and then to divide by 10, we can move the digits one place value to the right, and zeros can disappear off the end of our place value chart. So we've divided by 10. Now, 52,000 divided by what is 52? Well, here our missing number is 1000 because we need to cancel all three of our end zeros to get 52 as our answer. 52,000 divided by 1000 is 52 because we have 3 end zeros in 1000, so we can cancel all 3 of the end zeros in our dividend to get 52 divided by 1. And what's really happened here is that we've started with 52,000 and then by dividing by 1000 we've moved the digits 3 squares to the right to get 52 as our answer. Now 830,000 divided by what is 8,300? Well, here our missing number is 100 because to get our answer we need to cancel 2 of our end zeros and we have 2 end zeros in 100. So 830,000 divided by 100 gives us the same answer as 8,300 divided by 1 because we can cancel 2 of our end zeros. And again, what's really happening is that we start with 830,000 and then the digits move 2 place values, so 2 squares to the right to get 8,300 as our answer. Now we need to divide using short division. So first we have 5,862 divided by 3. So we can set the question out like this, with the divisor, the number that we're dividing by, on the left. Now we start by dividing the larger place values. So first we have 5 divided by 3. So we need to think of a number in the 3 times table that's as close to 5 as possible, but not more than 5. So 6 is in the 3 times table, but 6 is too many. We need to think of a number less than 5. So that's 3. And because 1 times 3 is 3, we write 1 above the digit in our answer line. But 1 times 3 is 3, and we need 2 more to get to 5. So 2 is our remainder, and we write that in front of the next digit. So now, rather than 8 divided by 3, because we wrote our remainder in front of the digit, we need to divide 28 by 3. So the closest number in the 3 times table to 28, which is still not more than 28, is 27. And because 9 times 3 is 27, we write 9 in our answer line. But that's only 27, and we were dividing 28. From 27, we need 1 more to get to 28, so we have a remainder of 1. 9 times 3 is 27, but we need one more to get to 28, so 1 is our remainder, and we write that in front of the next digit, so now we need to divide 16 by 3. The closest number to 16 in the 3 times table, which is still less than 16, is 15, and 5 times 3 is 15, but then from 15 we need one more to get to 16, so we have a remainder of 1, and we write that in front of the next digit. So now we have 12 divided by 3. That's exactly 4, because 4 times 3 is 12. So our answer is 1954. The one thing to remember when we're dividing using short division is that the remainder will always be less than the divisor. So because we're dividing by 3, if we get a remainder, the remainder can only be 1 or 2. It can't be 3 or more. So now let's try 5,184 divided by 6. We can set the question out in the same way, but now if we look at our first digit, we have 5 divided by 6. But 5 is less than 6. So what we can do here is either write 0 up here and then write a remainder of 5 in front of the next digit, or what I like to do when we have the first digit being less than the divisor is to take the first 2 digits together and divide 51 by 6. So to divide 51 by 6, we need a number in the 6 times table which is as close to 51 as possible, but not more than 51. The closest number in the 6 times table is 48, and because 48 is 8 times 6, we can write 8, so the number we need to times by, in our answer line. But 8 times 6 is 48, and we have 51. From 48, we need to count on 3 more, or we need to add 3 to get to 51. So we have 8 remainder 3, and we write the remainder in front of the next digit. So we can check that that makes sense, because 8 times 6 is 48, plus 3 is 51. So now, rather than dividing 8 by 6, because we have our remainder 3 in front of it, we need to divide 38 by 6. Now the closest number to 38 in the 6 times table, which is still less than 38, is 36. And because that's 6 times 6, 6 times 6 is 36, so we write 6 in our answer line, but from 36, we need 2 more to get to 38, so we write our remainder 2 in front of the next digit. So now we have 24 divided by 6. That's exactly 4, so our answer is 864. Finally, we have 9,863 divided by 7. If we look at the first digit first, we have 9 divided by 7. That's 1 remainder 2, because 1 times 7 is 7, but then we need 2 more to get to 9. Now we have 28 divided by 7. Well, 28 is in the 7 times table. That's exactly 4 times 7, so we write 4 in our answer line, but because 4 times 7 is exactly 28, we don't have a remainder. So we can just move on to the next digit. We have 6 divided by 7, but 6 is less than 7, so we have 0 remainder 6. 0 times 7 is 0, and then we need 6 more to get to 6. So finally, we have 63 divided by 7. That's 9, because 9 times 7 is exactly 63. So our answer is 1,409. So let's have a look at this first question again, and let's think about why we write the remainder in front of the next digit. So for this question, we were dividing 5,862, so that's 5 thousands, 8 hundreds, 6 tens, and 2 ones, and we were dividing by 3, so we can share these place value counters into 3 groups. Remember, we start by dividing the larger digits, so we had 5 thousandths divided by 3. We can share out 3 of these thousandths, but then we get a remainder of 2. And the reason why we write our remainder in front of the next digit is that we can exchange 1,000 place value counter for 10 hundredths. And when we do this, you can see that we have 28 hundredths, 2800 place value counters altogether. So we're dividing our 28 hundredths by 3. We can share out 27 of those hundredths because 9 times 3 is 27, so we have 900 place value counters in each of our groups. But there's one 100 place value counter that we can't share out. So that's our remainder, and remember, we write the remainder in front of the next digit, so in front of our 6 tens. And we can do that because we can exchange 100 place value counter for 10 place value counters. So now we have 16 tens altogether. We can share out 15 of those tens because 5 times 3 is 15, but then we have one remaining 10. We write the remainder 1 in front of the next digit because we can exchange this 10 for 10 ones. So now we have 12 ones, and we can share out all of those ones to get 4 ones in each group. So that's why our answer is 1,954. Then we had 5,184, so there's 5 thousandths, 100, 8 tens, and 4 ones. We're dividing by 6, so we need to share these place value counters out between our 6 groups. We can't share out our 1,000 place value counters because we only have 5 of them, but we have 6 groups, and with division we need to make groups of the same size. But we can exchange each of our 1,000 place value counters for 10 hundred place value counters, and that gives us 5,100 place value counters altogether. We can share out 48 of those because 8 times 6 is 48, so we get 800 counters in each of our groups. But we have 300 counters that we can't share out, so we write the remainder 3 in front of the next digit, so in front of our tens digit, and that's because we can exchange each of our 100 counters for 10 counters. That gives us 38 10 counters. We can share out 36 of those with 6 in each of our groups. We write the remainder in front of the next digit because we can exchange these tens for 10 ones. So now we have 24 ones which we can share out with 4 ones in each group. So that's why our answer is 864. For our last question, we had 9,863 divided by 7. So that's 9 thousandths, 8 hundredths, 6 tens, and 3 ones, and we're sharing these counters into 7 groups. We can share out 7 of our thousandths to get 1,000 counter in each of our groups. We have a remainder of 2 thousandths which we can't share out, but we can exchange these for 10 hundredths. So that gives us 28 hundredths altogether. We can share out all 28 of these hundredths because 4 times 7 is 28, so that's why we wrote 4 as the hundredths digit of our answer. But now we have 6 tens. We can't share out 6 tens because we have 7 groups. So we have 0 tens in our answer, but we can exchange these 6 tens for 60 more ones. That gives us 63 ones altogether, and we can share out all of these to get 9 ones in each group. So that's why our answer is 1,409, because in each of our groups we have 1,000 counter, 400 counters, no 10 counters, and 9 1 counters. Now for these questions, we're dividing using short division, but we're going to get remainders in our answers. So first, we have 5,862 divided by 5. So we can set the question out like this, with the number that we're dividing by, or the divisor, on the left. Using short division, we start by dividing the larger place values. So first, we have 5 divided by 5. That's exactly 1, because 1 times 5 is 5. So we don't have a remainder here, so we can move on to the next digit, and 8 divided by 5 is 1, remainder 3. That's because 1 times 5 is 5, but then from 5 we need 3 more, or we need to add 3 to get to 8. So now we have 36 divided by 5. So we need to think of a number in the 5 times table that's as close to 36 as possible, but not more than 36. The closest number to 36 in the 5 times table is 35, and because that's 7 times 5, we write 7 in our answer line. But 7 times 5 is 35, and we were dividing 36. From 35, we need 1 more to get to 36, so our remainder is 1. But now we have 12 divided by 5. The closest number to 12 in the 5 times table is 10, and that's 2 times 5. But 2 times 5 is 10, and we need 2 more to get to 12, so we get a remainder of 2 in our answer. So that's 1,172, remainder 2. We could have spotted straight away that for this question we were going to get a remainder, because remember, all multiples of 5 end in a 5 or a 0, and here we were dividing a number that ends in a 2. So now we have 4,989 divided by 9. If we look at the first digit, we have a 4, but 4 is less than 9. So when this happens, either we can write 0 and a remainder of 4 in front of the next digit, or we can just take the first 2 digits together and divide 49 by 9. The closest number to 49 in the 9 times table, which is still less than 49, is 45. And because 45 is 5 times 9, we write 5 in our answer line. But 5 times 9 is 45, and we need 4 more. We need to add 4 to get to 49. So our remainder is 4, and we can write that in front of the next digit. So to check, 5 times 9 is 45, plus 4 is 49. So now we have 48 divided by 9. Again, the closest number to 48 in the 9 times table, which is still less than 48, is 45. 45 is 5 times 9, so we write 5 in our answer. But 5 times 9 is 45, and we need 3 more. We need to count on or add 3 from 45 to get to 48. So 3 is our remainder, and we can write that in front of the next digit. So now we have 39 divided by 9. That's 4, remainder 3, because 4 times 9 is 36, but then from 36 we need to count on 3 more to get to 39. So our answer is 554, remainder 3. Finally, we have 8,861 divided by 6. If we look at the first digit, 8 divided by 6 is 1, remainder 2, because 1 times 6 is 6, and then we need 2 more to get to 8. Now we have 28 divided by 6, so we need to think of a number in the 6 times table which is as close to 28 as possible, but not more than 28. The closest number that's still less than 28 is 24, and because 4 times 6 is 24, we write 4 in our answer line. But 4 times 6 is 24, and we need 4 more to get to 28, so our remainder is 4. Now we have 46 divided by 6. The closest number to 46 in the 6 times table, which is still not more than 46, is 42. 7 times 6 is 42, but we need 4 more from 42 to get to 46. So to check, 7 times 6 is 42, plus 4 is 46. Now we have 41 divided by 6. The closest number to 41 in the 6 times table that's not more than 41 is 36. We can't use 42 because that would be too many. So 6 times 6 is 36, but then from 36 we need to add 5 to get to 41. So we have 6 remainder 5. Again, remember when we're dividing, the remainder can't be more than the number we're dividing by, or the divisor. So here, because we're dividing by 6, our remainder can only be 1, 2, 3, 4, or 5. And this is a good thing to check once you've finished a question to make sure that you've not made any calculation errors. So our answer is 1,476, remainder 5. So let's take another look at this first question we solved. We had 5,862, so that's 5,000, 8 hundreds, 6 tens, and 2 ones. We were dividing by 5, so we can share these place value counters out into 5 groups. We can share out all of our thousands to make 1,000 in each group, so that's why we have 1 as the thousands digit of our answer. So now we can divide our 8 hundreds by 5. We can share out 5 of these hundreds to get 100 in each group, but then we have 3 hundreds that we can't share out, because remember, when we divide, we need each group to be the same. So our remainder is 3, and the reason we can write that 3 in front of the tens digit, remember we write the remainder in front of the next digit, and we can do that because we can exchange each of our 100 place value counters for 10 tens. So that means we have 36 tens to share out altogether. We can share out 35 of those tens, and we get 7 tens in each of our groups. So that's why we get 7 as the tens digit of our answer. We have 1 remaining 10 which we can't share out, but we can exchange that 10 for 10 ones, so we get 12 ones. But we can only share out 10 of those ones, with 2 ones in each group. But then there are 2 ones that we can't share out, and that's why we get a remainder of 2 as our answer. So then we had 4,989, so 4,000s, 900s, 8 tens, and 9 ones. And we were dividing by 9, so we need to share these place value counters out into 9 equal groups. We can't share out our thousands because we only have 4 counters, but we're dividing into 9 groups. So what we can do is exchange each of these thousands for 10 hundreds. That means that we now have 49 hundreds altogether. We can share out 45 of these hundreds, and we get 5 counters in each group, so that's why we have a 5 in the hundreds digit of our answer. And we can write our remainder 4 in front of the tens digit, because instead of 4 hundred counters, we can have 40 10 counters to give us 48 tens altogether. We can share out 45 of these to get 5 tens in each group, and 3 tens which we can't share out. We can turn these 10 counters into ones, and that means that we have 39 ones. But we can only share out 36 of these ones, because remember, when we're dividing, we need equal groups. So we have 4 ones in each of our groups, but then we have 3 remaining counters that we can't share out, and that's why our answer is 554, remainder 3, because in each of our groups we can have 5 hundreds, 5 tens, 4 ones, but then there are 3 one counters that we can't share out. So here we have some missing digit division problems. So first we can see something has been divided by 3 to give an answer of 1. Now you might think this digit here has to be a 3, but remember, with short division we get remainders, and if we look at the next place value along, we have 2 divided by 3, but we have 7 in our answer. So we haven't divided 2 by 3 to get 7. We must have divided 22 by 3 to get 7 remainder 1, because 7 times 3 is 21, and then we need 1 more to get to 22. So now let's think back to this first box. We need to think of a number that divides by 3 to give an answer of 1 remainder 2. This digit here must be a 5, because 5 divided by 3 is 1 remainder 2, because 1 times 3 is 3, and then we need 2 more to get to 5. So now, for this box, we have 1 as our remainder, and we've divided by 3 to get 5. If we look at the next place value along, we have 6, and that divides exactly into 3, so there was no remainder for this box here. That means that this digit must be a 5, because 15 divided by 3 is exactly 5 with no remainder, because 5 times 3 is exactly 15. So now we just have 6 divided by 3, which is 2. So what we can do now to make our answer clear is just to rub out our working and just leave the missing digits in the boxes. Now, for this box here, we have something divided by 5, but notice that we don't have a digit in our answer line. So they must have taken the first 2 digits together. Now 6 times 5 is 30, so this digit here must be a 3, because 32 divided by 5 is 6 remainder 2. So now we have 26 divided by 5, which is 5 remainder 1, and now something divided by 5 is 3. Well, 15 divided by 5 is 3, because 3 times 5 is 15, so this digit must be a 5. Again, we can rub out our working and just leave the missing digits in the answer boxes. Now here we've divided 9 by 4 to get 2, and there must have been a remainder of 1, because 2 times 4 is 8, plus 1 is 9, so we need to write the remainders in ourselves. So now we have 12 divided by 4. That's exactly 3, because 3 times 4 is 12. Now here, something divided by 4 is 0. Now you might think this missing digit must be a 0, because 0 divided by 4 is 0. But remember, with short division, we can get a remainder. And for this box, we've divided by 4 to get 6. So in this box here, we must have divided 24 by 4 to get 6. So we need a digit in this box, which is going to give us a remainder of 2. Well, 2 divided by 4 is 0 remainder 2, so this digit here has to be a 2. Again, we can rub out our working, and we found all of our missing digits. Now there was another way that we could have solved this problem. As soon as we'd worked out that this box here was a 3, what we could have done is multiply our answer or our quotient by the divisor. So 6 times 4 is 24, 0 times 4 is 0 plus 2 is 2, 3 times 4 is 12, so 1, 2, 2 times 4 is 8, plus 1 is 9. So that gives us 9,224, so that must have been our dividend. Now for these questions, we start with multiples of 10, so numbers that end in a 0, and we're dividing by numbers which are also multiples of 10. So first we have 420 divided by 70. Now what we can do with division questions is cancel our end zeros. So because both numbers in the question end in a 0, we can cross out these zeros and then just answer 42 divided by 7, which is 6. So that's also the answer to 420 divided by 70. Now we have 360 divided by 60. Again, with division questions, we can cancel our end zeros, so 360 divided by 60 will give the same answer as 36 divided by 6, which is 6. Finally, we have 720 divided by 90. Both numbers are multiples of 10, so we can cancel our end zeros, and 72 divided by 9 is 8, so that's also our answer to 720 divided by 90. So remember, when we're dividing multiples of 10, we can cancel our end zeros to solve these problems mentally. And that makes sense if we remember that one way to divide is to count up in steps of the divisor until we get to the dividend. So we can count on in steps of 70 until we reach 420. We have 70, 140, 210, 280, 350, and then the sixth multiple of 70 is 420, and that's why 420 divided by 70 is 6. Now here we're dividing by 60, so we can count up in steps of 60 until we reach 360. We have 60, 120, 180, 240, 300, and then the sixth multiple of 60 is 360. Now, to divide by 90, we could count up in steps of 90 until we reach our dividend. So we have 90, 180, 270, 360, 450, 540, 630, and then the eighth multiple of 90 is 720, and that's why 720 divided by 90 is 8. Now for these questions, we start with multiples of 100, so numbers that end in 2 zeros, and we're dividing by multiples of 10, so numbers that end in 1 zero. First, we have 600 divided by 20. Now what we can do when we have division questions with end zeros is cancel the end zeros. So 600 divided by 20 will give us the same answer as 60 divided by 2. That's 30 because 6 divided by 2 is 3, and then if we have an end zero in the dividend that we haven't been able to cancel, we'll have an end zero in the quotient. So our answer is 30. Now we have 3,500 divided by 50. We have one end zero in the number that we're dividing by, so we can cancel one end zero. So now we have 350 divided by 5. That's 70 because 35 divided by 5 is 7, and then because we have an end zero in the dividend that we've not been able to cancel, we have an end zero in the quotient. So our answer is 70. Now let's try 2,700 divided by 30. We only have one end zero in the divisor, so we can only cancel one end zero. That means that we have 270 divided by 3. That gives us an answer of 90, because 27 divided by 3 is 9, and if we have one end zero in the dividend, we need an end zero in the answer. so that's 90. So 600 divided by 20 gives us the same answer as 60 divided by 2. Instead of working out 3,500 divided by 50, we know that that will give us the same answer as 350 divided by 5. And then again, if we have one end zero in the divisor, we can cancel an end zero, so just work out, for this question, 270 divided by 3. And this makes sense if we remember that one way to divide is to count up in steps of the divisor until we reach the dividend. But here, it would take us a long time to count up in steps of 20 until we reached 600. So instead, let's count in steps of 10 times 20, so in steps of 200. 10 times 20 is 200. If we add another 10 lots of 20, that would take us to 400, and then another 10 20s would take us to 600. So, because we've counted on 10 lots of 20 3 times, we've counted 30 steps of 20 altogether. Now we have 3,500 divided by 50. Instead of counting in steps of 50, we could count in steps of 10 times 50, so in steps of 500. We have 500, 1,000, 1,500, 2,000, 2,500, 3,000, and then 3,500. So we counted 10 lots of 50 7 times, so that's why our answer is 70. And now here, on a number line, instead of counting in steps of 30, we can count in steps of 300, because that's 10 lots of 30. If we add another 10 lots of 30, that takes us to 600. Then we have 900, 1,200, 1,500, 1,800, 2,100, 2,400, and then 2,700. So, because we counted in steps of 10 times 30 9 times, our answer is 90. Now for these questions, we're dividing a multiple of 100 by a multiple of 100. First, we have 600 divided by 200. Now when we have division questions with end zeros in both the dividend and the divisor, what we can do is cancel those end zeros. So 600 divided by 200 will give us the same answer as 6 divided by 2, so that's 3. Now let's try 3,500 divided by 500. We have two end zeros in both the dividend and the divisor, so we can cancel those end zeros, and 35 divided by 5 is 7, so that means that 3,500 divided by 500 must also be 7. Now we have 2,700 divided by 300. We can cancel our end zeros, and 27 divided by 3 is 9, so that's our answer. So remember, 600 divided by 200 gives the same answer as 6 divided by 2. 3,500 divided by 500 gives the same answer as 35 divided by 5, and we can cancel our end zeros in this last question as well and just answer 27 divided by 3. And this makes sense if we remember that one way to divide is to count up in steps of the divisor until we reach the dividend. So if we count in steps of 200, we have 200, 400, and then the third multiple of 200 is 600. So because we made 3 jumps, we know that 600 divided by 200 is 3. Now let's count in steps of 500 until we reach 3,500. We have 500, 1,000, 1,500, 2,000, 2,500, 3,000, and then 3,500. So we've made 7 jumps. And now for this last question, we could count in steps of 300 until we reach 2,700. Now here we have some missing number problems for multiplying multiples of 10 or 100. So first, 7 times what equals 2,800? Well, 7 times 4 is 28, but then because we have two end zeros in the answer to our multiplication, we must need two end zeros in the question. So our missing number is 400. That's because 7 times 4 is 28, and then we need two end zeros in our multiplication question because we have two end zeros in our answer. Now this next problem isn't really a missing number problem at all, because all we have on this side of the equal sign is an answer box, and it doesn't matter whether the equal sign is at the start or at the end of a calculation, we do the same thing. So we just need to multiply 9 by 800. Well, 9 times 8 is 72, and then because we have two end zeros in our question, we need two end zeros in our answer. So our missing number, or our answer, is 7,200, because 9 times 8 is 72, and then we need two end zeros. Now, what times 90 equals 450? Well, 5 times 9 is 45, and we have an end zero in both the question and the answer, so our missing number is just 5. 5 times 9 is 45, and then we have an end zero in the question, so we have an end zero in the answer. What times 7 equals 630? Well, 9 times 7 is 63, but because we have an end zero in the answer to our multiplication, we need an end zero in the question as well. So 9 times 7 is 63, and we need our end zero, so our missing number is 90. What times 300 equals 1,500? Well, 5 times 3 is 15. We have two end zeros in our answer, but we already have two end zeros in our question, so our missing number is just 5. 5 times 3 is 15, and then because there's two end zeros in the question, there's two end zeros in the answer. Now, what equals 6 times 50? Again, like the problem we solved up here, this isn't really a missing number problem, because we don't have anything else except for an answer box on this side of the equal sign. Now 6 times 5 is 30, but because there's an end zero in our multiplication question, we need to write an end zero after the 30. So 300 equals 6 times 50, because 30 is 6 times 5, and we need our end zero. Now 200 times what equals 140,000? Well, 2 times 7 is 14, but here we have a total of 1, 2, 3, 4 end zeros in our answer, so we're going to need a total of 4 end zeros in the question. We already have two end zeros here, so we need two more end zeros, so that we have 4 end zeros in both the question and the answer. So 200 times 700 is 140,000, because 2 times 7 is 14, and then we have 4 end zeros in the question, 2 here and 2 here, and that means we have 4 end zeros in the answer. Something times 800 equals 24,000. Well, 3 times 8 is 24, and in our answer we have 3 end zeros. We already have 2 end zeros in our question, so we need just one more end zero. 3 times 8 is 24, so 30 times 800 is 24,000, because then we've got 3 end zeros in both the question and in the answer. 40 times what equals 1200. Well, 4 times 3 is 12, but in our answer we have 2 end zeros. We already have one end zero in our question, so we need just one more end zero. 4 times 3 is 12, so 40 times 30 is 1200, because then we've got 2 end zeros in both the question and in the answer. Finally, what times 50 equals 25,000? Well, 5 times 5 is 25, but then we have 3 end zeros in our answer. We already have one end zero in our question, so we need 2 more end zeros so that we have 3 end zeros in our question altogether. So 5 times 5 is 25. That means that 500 times 50 is 25,000. Now we have some missing number division problems for multiples of 10 or 100. So first, 3,600 divided by what equals 6? Well, if we ignore the zeros for a moment, we know that 36 divided by 6 is 6, because 6 times 6 is 36. Now in this question, we have 2 end zeros in our dividend, but we don't have any end zeros in our quotient. So these end zeros must have been cancelled by our divisor. So if we write 2 end zeros in our divisor, we can see that 3,600 divided by 600 is 6, because 36 divided by 6 is 6, and then we've cancelled our end zeros. Now, what divided by 8 equals 70? Well, 56 divided by 8 is 7, because 7 times 8 is 56. But here we have an end zero in our quotient. We don't have any end zeros in our divisor, so there must have been an end zero in our dividend. 560 divided by 8 is 70, because 56 divided by 8 is 7, and if we have an end zero in our dividend which we've not been able to cancel, we will have an end zero in our quotient. Now, what divided by 5 equals 600? If we ignore the zeros for a moment, we know that 30 divided by 5 is 6, but we have 2 end zeros in our quotient. We don't have any end zeros in our divisor, so after the 30, we need to write 2 end zeros in our dividend. 30 divided by 5 is 6, and that means that 3,000 divided by 5 is 600. Remember also, division problems can be read backwards as multiplication problems, so we could have got our missing number by multiplying 600 by 5 to get 3,000. 720 divided by what equals 8? Well, 72 divided by 9 is 8, because 8 times 9 is 72. But we have an end zero in our dividend, and we don't have any end zeros in our quotient, so this end zero must have been cancelled by our divisor. So we need an end zero in our divisor, because 72 divided by 9 is 8, which means that 720 divided by 90 is also 8. Now, what divided by 800 is 7? Well, 7 times 8 is 56, but we need 2 end zeros after the 56, because we don't have any end zeros in our quotient, and that means the end zeros in the question must have been cancelled, and because we have 2 end zeros in the divisor, we need 2 end zeros in the quotient. What divided by 40 equals 8? Well, 8 times 4 is 32, and then because we don't have any end zero in our quotient, we know that this end zero in our divisor must have been cancelled. So 32 divided by 4 is 8, And because we can cancel the end zeros, we know that 320 divided by 40 must also be 8. 350,000 divided by what equals 700? Well, 35 divided by 5 is 7. Here we have 2 end zeros in our quotient, but we have a total of 4 end zeros in our dividend. So 2 of these end zeros must have been cancelled with our divisor. So we need 2 end zeros in our divisor. 3,500 divided by 5 is 700, because the zeros that we've not cancelled in our dividend need to be written in our quotient as well. But that means that 350,000 divided by 500 is 700. What divided by 200 equals 90? Well, 9 times 2 is 18. We can see in our answer we have 1 end zero, but there are 2 end zeros in our divisor. That means 2 end zeros must have been cancelled from our dividend, but because we still have an end zero in our quotient, there must have been another end zero. So we need 3 end zeros altogether. That's because 2 of our end zeros can be cancelled, and then 180 divided by 2 is 90, because the end zero in our dividend, which we couldn't cancel, must appear in our quotient as well. What divided by 700 equals 700? Well, 7 times 7 is 49. Here we have 2 end zeros in our divisor, so they must have been cancelled, but we still have 2 end zeros in our quotient. That means there must have been 4 end zeros in our dividend. That's because 4,900 divided by 7 is 700, because the 2 end zeros that we couldn't cancel appear in our quotient, but then the 2 end zeros have been cancelled. Now for this question, it might also have been useful to remember that division problems can be read backwards as multiplication problems, so we could have worked out 700 times 700. 7 times 7 is 49, but then because we have a total of 4 end zeros, there must be 4 end zeros in our answer. 64,000 divided by what is 800? Well, 64 divided by 8 is 8, but then we need an end zero. That's because we can cancel 1 end zero, and that would leave us with 2 end zeros in our dividend, so that's why we have 2 end zeros in our quotient. 6,400 divided by 8 is 800, so 64,000 divided by 80 must also be 800. Something divided by 60 equals 20. Well, 2 times 6 is 12, but then we need 2 end zeros. That's because one of our end zeros gets cancelled by our divisor, but then we still have an end zero in the dividend, so we have an end zero in our quotient. 120 divided by 6 is 20, so 1,200 divided by 60 is also 20. Finally, we have 2,400 divided by something equals 60. 24 divided by 4 is 6, but we can see that we have 2 end zeros in the dividend, but only 1 end zero in the quotient. So one of these end zeros must have been cancelled by an end zero in our divisor. 240 divided by 4 is 60, and that means 2,400 divided by 40 is also 60.